You ever wonder what an AI is really thinking? I mean, we know they can learn these incredible things, right? From mastering games to controlling robots, but figuring out what they've actually learned, what rules they're following, that has been one of the biggest mysteries in AI. Well, today, we're going to look at a new approach that might just be the key to finally unlocking their reasoning. So let's get right into it. The heart of the issue is what experts call the black box problem. And it's exactly what it sounds like. With most of our advanced AIs, we see the data that goes in and we see the results that come out, but the how, the process in the middle, is a total mystery. It's just a giant, complex web of numbers, and that makes them incredibly hard to debug, to verify, and, most importantly, to trust. And this leads to a really fundamental question. Just imagine trying to learn a new board game. But instead of a rule book, all you can do is watch an expert play, over and over again. And your job is to somehow guess their secret strategy just by watching their moves. That is exactly the challenge AI researchers have been up against. Now, this challenge actually has a name. It's called inverse reinforcement learning, or IRL. And it's a really powerful idea, right? Instead of us programming the rules, the AI learns the rules just by watching. But here's the catch with the old way of doing it. They solve one black box problem by creating, well, another one. The rules the AI learns are still just a confusing tangle of numbers. So yeah, it might work, but it doesn't solve that fundamental problem of trust. This really highlights two totally different philosophies. On one side, you've got the traditional black box approach. These models, they're powerful for sure, but they're mysterious, they're hard to debug, and they need just massive amounts of data to learn anything. But on the other side is this revolutionary new idea, an open book model, something that's transparent, easy for us to inspect, incredibly data efficient, and trustworthy from the ground up. And that brings us to the hero of our story today. So, let's meet Grace. It is a completely new way of thinking about this, and its name tells you everything you need to know. Grace stands for generating rewards as code. You see, instead of learning an unreadable mess of numbers, Grace learns to write its goals as something we can all understand. Simple computer code. And this, right here, is the core breakthrough. The goal isn't just a set of numbers locked away in a box anymore. It's actual, executable code that a programmer can read, understand, and double-check. Grace isn't trying to build a better black box. It's getting rid of the box completely. Okay, so how in the world does an AI learn to write code that captures a really complex goal? Well, the process is incredibly clever. It's actually inspired by millions of years of evolution. It's basically a survival of the fittest competition, but instead of animals, it's for little snippets of code. The technique is called evolutionary search. And I want you to imagine Grace starting with a whole population of tiny little code programs. Each one is a different guess at what the expert's rules might be. Then it throws them into this brutal competition. It randomly changes them, it mashes them together, and it tests them to see which ones do the best job of explaining what the expert did. The weak, ineffective programs, they get tossed out. The strongest ones survive to create the next generation of even better, smarter code. So this whole process really breaks down into three key phases. First, there's goal identification. A large language model watches an expert and makes a rough first guess. Second, reward refinement. This is where it unleashes that survival of the fittest evolutionary search we just talked about, constantly making its code better. And third, and this is the really clever part, it does active data collection. A totally new AI agent takes the best code so far and actively tries to break it, to find weird edge cases and flaws. And then that new data gets fed right back into the loop, making the next generation of code even more robust. Okay, that all sounds great in theory, right? But does it actually work? Well, to find out, the researchers put Grace through its paces in some really tough environments, everything from simulated mazes to controlling a real Android device. And the results were, well, they were pretty staggering. And I'm not exaggerating when I say the results were seriously impressive. Across a whole bunch of difficult tasks, Grace didn't just do well, it completely changed the game in terms of performance and efficiency. Let's look at the data. Check this out. The PPO Oracle column on the left, that's basically a perfect score. It's an AI that was given the answers, like a cheat sheet. In the middle, you've got jail, a top-tier black box method. And on the right, you have Grace,
So on the simpler tasks, Grace gets a perfect score, matching the one that cheated, while the traditional method really struggles. And even on a much more complex multitask challenge, Grace is nearly flawless. But believe it or not, that isn't even the most amazing part.
Remember how I said Gale struggled? It was trained on 2,000 expert examples. And Grace, it got those near-perfect scores after watching just 8. That is not a typo. 8 examples versus 2,000. This is a monumental leap in data efficiency. It just shows how incredibly fast this open book approach can learn. But Grace doesn't just figure out the final goal. It also learns how to give helpful little hints along the way. It's a concept called reward shaping. In its first generation of code, the AI was technically correct, but the hints weren't very good, so it only had a 10% success rate. But by the 4th generation, Grace had evolved its own code to give much smarter rewards, and you can see its performance just rocketed up to 90%. So let's zoom out for a second. This isn't just about one clever algorithm. The very idea of generating rewards as code could fundamentally change how we build and how we interact with AI systems. But maybe the most powerful idea here is that Grace isn't just solving one task at a time and then forgetting everything. It's actually building on its knowledge. Over time, it's creating a reusable library of code, kind of like its own reward API that helps it understand the world.
What the researchers found was that in the early stages, Grace is like a kid experimenting, creating lots of new, simple functions just to try things out. But as it gets smarter, it stops creating so much new code and starts reusing the most effective functions it already built. Little modules, like a function to find its own position, or one to check if an object is the target. Just like a good human programmer, it learns to be modular and efficient, building up this library that helps it learn new tasks way faster.
So when you put all of this together, what's the real payoff? Well, it boils down to 4 huge breakthroughs. First, transparency, because we can finally read and understand an AI's motivations. Second, efficiency, because it learns from an unbelievably small amount of data. Third, trust, because if we can verify the code, we can finally start to genuinely trust the system. And finally, generalization, because that reusable code library helps it tackle new problems so much more easily. And this leaves us with one final and pretty fascinating question. For decades, AI has been this incredibly powerful but mysterious force. But if it can finally show its work, if it can write its own rules in a language that we can actually understand, is this the beginning of a future where we can finally, truly learn to trust it?